Technology is an essential tool for the modern world, with a lot of positive aspects that we use day after day. The population growth in the last 50 years has reached the figure of more than 7 billion people today. Therefore, it's estimated that by 2050, we'll be close to 10 billion people. With the aforementioned added to the globalized and consumerist lifestyle, it's projected that 20% increase each year in the consumption of electronic devices. In 2019, 53.6 million tons of technological waste were produced, according to the United Nations University and the International Solid Waste Association, and it's estimated that by 2050 it could reach 120 million tons. So you may wonder, where did these discarded technological devices finally end up? Only 17.4% of the e-waste produced in 2019 reached formal management or recycling facilities, according to the most recent GESB estimates. The rest was disposed or illegally, mostly in low or middle-income countries, where informal workers recycle it. In other words, the world is facing a tsunami of e-waste that puts our lives and health at risk, according to Dr. Tedros Adhanom, Director General of the World Health Organization. It has been estimated that 4.2 million tons of electrical and electronic waste were generated in Latin America, equivalent to an average of 7.1 kilograms per habitant. The Latin American countries with the highest relative amounts of e-waste generation are Brazil, 1.5 million tons, Mexico, 1 million tons, and Argentina, 0.4 million tons. The three Latin American countries with the highest relative amounts of e-waste generated are Uruguay, 10.8 kilos per inhabitant, Chile, 8.7 kilos per inhabitant, and Argentina, 8.4 kilos per inhabitant.
E-waste is the fastest growing type of waste in the world and poses social and environmental risks, said Peter Baker, President and CEO of the World Business Council for Sustainable Development. For this reason, we have searched for a solution to help reduce e-waste pollution by making use of Internet cables, connectors, among others. The ecological concrete will consist of Portland cement, fine sand, coarse sand, water, and plastic-coated copper wire fibers. The article, a study on the effect of fibrous site on the strength of fibrous concrete mix made of recycled e-waste fibers, has found a feasible mix design, in which they evaluate mix design with different percentages of e-fiber to evaluate the properties it contributes to the mix. In the article, compression tests were performed with a total of 10 mixes, with percentages of electronic fiber, 0, 0.6, 0.8, and 1% of the weight of cement, and different fiber lengths, 2, 3, and 4 centimeters. The relative proportion of cement, fine and coarse aggregate, and water were obtained by the IS code method, with design reference M30 for casting concrete. The compressive strength test performed at 7 and 28 days obtained the following results. For 7 days, the highest value was 3111 Newton per square meter for the 0.8% cement weight designed with a fiber length of 3 centimeters. And for 28 days, the highest value was 4266 Newton per square meter for the 0.8% cement weight designed with a fiber length of 3 centimeters.
The importance of addressing the devastating effects of e-waste, which pose serious challenges, is related to the 2030 Agenda SDG 3, 6, 8, 11, 12, and 14, which in that order will be explained below. SDG 3, by 2030, reducing deaths and diseases caused by hazardous chemicals in air, water, and soil pollution. SDG 6, by 2030, achieving universal and equitable access to safe and affordable drinking water for all. SDG 8, by 2030, demand the protection of labor rights, promote the creation of decent employment, the eradication of forced and child labor. SDG 11, by 2030, reduce the negative attention to air quality and municipal and other waste management. SDG 12 by 2030 significantly reduce waste generation through prevention, reduction, recycling, and reuse. SDG 14. This mainly concerns pollution and the protection of the marine ecosystem besides the stored biodiversity and harm ecosystems. For these reasons, e-waste can be linked to the 2030 agenda.
The addition of fibers from electronic waste is a very effective and feasible method, because it reduces environmental problems and helps to increase the strength of concrete. Above all, it will prevent the appearance of cracks, which will increase the life of the structures. According to the percentages analyzed in the article, it's concluded that the optimum percentage is 0.8% by way of cement for a length of 3 cm of e-waste fiber. Because with this data the maximum value of compressive strength was reached. Due to these benefits, mainly physical and mechanical properties, we invite you to investigate this new favorable topic that provides an innovative solution by allowing the reuse of electronic waste to mitigate the threats of e-waste on the health and capacity of future generations.